Hey guys, this video is on shadows and their magnification. Magnification has to deal with the size of a shadow. How tall is it, things like that. So first write down your definition of magnification. It's the ratio of shadow height to object height. Or in other words, how many times taller a shadow is than the object. How much times taller the shadow is. The shadow we're going to be referring to as the image sometimes in this video. So create some space to fill in some equations and more space to draw a diagram, probably like a half or a third of a page for your diagram. All right, so take some time to write that down right now. Okay, now that you have created space for your equations and some place for a diagram here, let's draw our shadow diagram. First, on the left side, we have a light. You might notice that this light is different than our previous shadow diagram's light because it just looks like a dot. It doesn't look like a flashlight. And we're choosing a dot this time because we don't want to focus on fuzziness. Because flashlights have a certain width to them, some light comes from the top of the flashlight and the bottom of the flashlight. But if light only came from one point, like a pinhole poked in a piece of paper, there would be no fuzziness at all. All right. So this is kind of like your iPhone flashlight. It's tough to get fuzziness. Your iPhone is a little wide, but this is just a pinhole poked in a piece of paper. It's tough to say. And there's going to be no fuzziness in these magnification diagrams. All right, because there's no fuzziness, we're only going to be drawing two rays of light. So you don't really need different colored pencils for the magnification diagrams, unlike the fuzziness ones that we drew before. I want you to, and if you didn't, you could pause right now and redraw your object. I want you to place your object right in the center. You could measure with your ruler that you should have with you. If you don't have one, go pause and grab one because you'll need to make some measurements. But place your object right smack dab in the center between the light and the screen as best you can there, okay? And the screen will be where the shadow shows up. So our rays of light are pretty much the same as we drew last time. One ray will skim the head. And the other ray will skim the feet. Okay. So those rays skim the head and skim the feet, and you have a sharp shadow between those two lines that show up on the screen. Okay, now we need to make some measurements, okay? So we're going to start with some heights, since magnification has to do with how tall the shadow is. We're going to start with a variable called HO. This is called height of the object. Okay, so label HO here next to the person. The height of that person would be HO. Whatever object you have. I like to draw stick figures. And take your ruler and measure the height of that person. You're not going to get the same number I have, and don't write down the same number. You might notice I'm using centimeters. From their feet to their head, what is their height? I have 3.2 centimeters. Just don't copy my numbers. Use this as an opportunity to practice measuring. Actually, I'd like to see when you submit your notes that you don't have the same exact number. It's impossible for you to draw the same exact one, I think. Our second variable is the height of the image. Remember, the image is our shadow over here. This is where the shadow shows up. So HI is the height of that shadow. So I'm going to measure the height between those two lines, and I get about 5.7 centimeters. All right. Now we have to do some variables for distance, because we have another equation where we can calculate magnification with distance from the flashlight. So DO is our first variable. That's called distance of object, right here. So our object, I'm going to measure to their waist, and I got about 10.1 centimeters. This is DO. Sorry, label it up DO. The distance of the object means how far is the object from the flashlight. Okay, so you start measuring distance at the flashlight for DO and finish it at the person. Distance of the image, in other words, is our next variable. In other words, that's the distance of the shadow from the flashlight. So this line is going to be DI. And let's see what number we get. And it goes all the way to the screen because that's where the shadow shows up. Distance of the image from the flashlight to the screen, mine is about 17 centimeters. Okay. Now I'm going to give you your equations on two different ways to calculate magnification. All right. Your first equation, HI over HO. Hi-ho, some people say. Students I've had in the past there. So HI divided by HO, and you can imagine that DI over DO will also work. And these equations are similar because they're kind of like similar triangles. You could see there's a small triangle here, and then there's a big triangle here. And there's a certain mathematical relationship which makes us be able to get those equations, all right? So now, you should have different numbers than I have here, okay, for your 4 measurements. But overall, we're going to use those numbers to calculate magnification. So let's calculate magnification with the height equation, HI over HO. And I'm going to keep this diagram so you can see it, how we're going to use it. We're just going to plug in the numbers. So HI is right here. I got 5.7. You probably have a different number. Remember, please pause the video if I go too fast. HO is right here. So that's 3.2 centimeters. So you need to divide. For me, I'm dividing the 5.7 by the 3.2 right now. 5.7 divided by 3.2. You have different numbers, but that's okay. I tried to place the guy midway, but it seems like I didn't really. It's probably closer to the screen. If he was midway, I would have got 2 for my magnification. But I got 1.78. All right. Now, what is the unit of magnification? 1.78 what? I mean, your science teachers for years have stressed, me included. Okay, so you can't just write a number without a unit. To what? A dozen what? Well, the weird thing here is centimeters is not the unit. Because when you divide, the centimeters cancels, which means you have no unit for magnification. Because the units cancel, it's just kind of like a 1.78 means 1.78 times bigger. That's it, you know? But there's no real unit you need to write. So keep that in mind when you're doing your answers. Don't write centimeters as a unit for magnification. This time I'm saying don't write a unit. It's kind of weird, right? Because the centimeters cancels out there. So the next thing we're going to do for magnification is we're going to use the distance equation, DI-DO, DI over DO. And let's use our diagram. All right, so in my diagram, DI is 17 centimeters. Yours is probably slightly different. And my DO is 10.1 centimeters. All right. All right, so the centimeters are going to cancel. And if I do this, you could see 17 over 10.1 is going to be pretty close to 1.78, which I got last time. 1.68. All right. Well, what you're looking for with these two answers, okay, is you calculated magnification twice, and you want to check both answers are similar. Mine are off by 0.1. If I subtracted those two numbers, I would get off by 0.1. If you're off by 0.2, that's okay. 0.3, you know, it's a little much. You should probably go make your measurements again, okay? But if you're off by 0.2 or less, is good. So make a note to yourself of that. If they're off by 0.2 or less, you're good. All right. You know you're doing a good job with these equations at calculating magnification. You don't need to use the same numbers I use. You know if you're good if they're off by 0.2 or less. And then you're doing a fantastic job with magnification. All right, guys. Good job.